Okay, here's the first extra credit problem. And the thing about this is you have to use a formula that we did not teach. Neither Mr. Vasquez nor I taught this particular formula, but it has to do with double angles. So notice on this picture right here, I have theta twice. So right now we know the sine of theta is 3 over 5, so we can know that sine of theta then, if that's 3 over 5, then this would be opposite over hypotenuse, and then we could find the value of cosine of theta by solving for this side. So I'm going to go ahead and bring this over here, and it's 3 over 5. I'm going to erase these from here because we actually don't know if these are 3 out of 5. We just know they're in a ratio of 3 and 5. It could have been 6 and 10 or 9 and 15. Okay, so it could have been any combination, but when they reduce, this ratio has to be 3 over 5. But we'll go ahead and do it over here. So here's my theta, and I can figure out what cosine theta is by using the Pythagorean theorem right over here. So cosine of theta, I need to find this side right here. I'll call that, let's call that b. So a squared plus b squared equals c squared, or hypotenuse squared. So I have a is 3, so 3 squared plus b squared is equal to the hypotenuse squared. 9 plus b squared is equal to 25. Subtract 9 from both sides, I get b squared is equal to 16. Square root that, and I get b is equal to 4. Okay, you might have also recognized it as a Pythagorean triple, in which case you don't need to do all this work. This work was just kind of if you didn't recognize it. So this side is 4. So what's the cosine of theta? Cosine of theta is equal to adjacent over hypotenuse. So we're using our SOHCAHTOA, 4 over 5. So if cosine of theta is equal to 4 over 5, what's the cosine of 2 times theta? Well, this is where our formula packet comes in handy. And we also have these formulas down here. And somebody is trying to break into my room right now. Go away. All right, so if I look on my formula packet, double angle formula, I actually have a couple things I can do. I know that cosine of 2 theta is equal to this. It's also equal to this. And it's also equal to this. So I can use any one of these to help me figure out what cosine of 2 theta is, because I have sine and I have my cosine, so I could use either one. Notice we also put that on your packet. They're also right here, written in a slightly easier to understand form. Okay, so I wanted to use, which one did I use? I used the one with the sine. I went ahead and used these, but you could have used any one of them. Okay, so I'm going to use that one. So to find cosine of 2 theta, I know cosine of 2 theta is equal to 1 minus 2 times sine squared theta. Okay, so usually people don't like using a formula that they haven't learned the derivation of, and the way that the IB textbook that we have introduces this formula, they really don't teach where it comes from. And I'm not sure I really want to go into it in class, so I'll probably end up just making another video. So for those of you who want to know where did this come from, you'll see where it came from. If we have time in class, we'll do the whole derivation as a class in class. But for right now, though, we're just going to go ahead and fake it till we make it. We have some formulas. Let's go ahead and see if we can use them. All right, so I know what sine of theta is. Now, what does this mean when it's got the little squared right there? That means you take sine of theta, this one right here, and you square it. Okay, very simple. So cosine of 2 theta is equal to 1 minus 2 times sine of theta is 3/5, so it's 3/5 squared. Okay, sine squared of theta, what does that mean? Sine squared of theta, that's the same thing as taking sine of theta, taking the value and squaring it. That's what it means. All right, so if we simplify this, 3/5 squared is 9/25. We're going to times that by 2 and subtract it from 1. So if we simplify that, we get 1 minus 18/25. Sorry, I should have written equals cosine of 2 theta. Should have written that first, but sorry, they just switched sides. So 1 is the same as 25/25. For those of you who forgot how fractions work, we need to have a common denominator before we can subtract them. So then we subtract 18 from 25, and we get 7. 7/25 is equal to the cosine of 2 theta. Okay, hence or otherwise. So in other words, when they say hence, that means you can use this answer, the previous answer, to find the next answer. They're giving you a big hint. You have to use this to get the length of BC. Okay, so where's BC? BC is right here. And notice BC is part of this right triangle. Okay, so if I copy that down, this big right triangle, I'm trying to find BC. Trying to find, that's a hypotenuse. My BC is a hypotenuse. BC is the hypotenuse. This whole angle right here is 2 theta. This is 2 theta because it's theta plus theta. So it's 2 theta. Ah, that's why they had us find cosine of 2 theta, because of this big triangle has an angle in it, which is 2 times theta, because there's 2 thetas. Now, they gave us some additional information, which we hadn't used yet, which is AC. AC is 14, and AC is right here. So this is 14. So now I know that cosine of 2 theta is equal to adjacent over hypotenuse. Okay, I can use my SOHCAHTOA again. It's adjacent over hypotenuse. So it's my adjacent is 14, and my hypotenuse, I don't know. That's what I'm trying to find. But I now have a value for the cosine of 2 theta. It's 7/25. So 7/25 is equal to 14 over h. Okay, I don't like having h on the bottom, so I'm actually going to rewrite my fractions. I'm going to take the reciprocal of each side of my equation. And now, to solve for h, all I have to do is multiply both sides by 14. So multiply both sides by 14. Times by 14. Oh, check that out. 7 goes into 14 twice. That's a 2. 2 times 25 is 50. So my hypotenuse is 50, which means that BC, the length of BC, is 50. Did they give us units? Yes, centimeters. We always want to put our units on. And that's it. That is extra credit problem number 1.